Okay, we're going to talk about understanding computer and network hardware and software ports. What are we talking about when we're talking ports and computers? Okay, so that's the subject for this video. So we're going to talk about introduction to ports, like what are they, hardware ports, what are they, software ports, what protocols are associated with ports, security and vulnerabilities, and future trends in port technology. So going to the introduction to ports, okay, so we're going to introduction to ports. Okay, a port is an interface that enables communication between devices, acting as a connection point for data exchange. All right, hardware ports such as USB connections provide physical interfaces for connecting various devices and peripherals. Software ports are used in networking to facilitate or help communication between applications and devices over a network. All right, so the software ports are used in networking, and hardware is the physical actual connection. So software ports are sort of like logical, not physical. Okay, this is showing an example of a port. You can probably seen USB ports, you know what they are. Ports play a crucial role, in fact, in connecting peripherals to computers, enhancing functionality and user existence. Ports facilitate data transmission between systems, enabling seamless communication and information exchange. Well, hopefully that's the case. And they optimize performance. Understanding ports is essential for optimizing system performance and ensuring reliability or reliable connectivity in networks. All right. So you've got to understand how this works in order to get the working like it should. Okay, hardware versus software. Okay, types of ports here. Hardware ports are physical interfaces on devices, such as these, that allow for direct, as in you plug something in, connections to peripherals and other hardware components. So that's where something's plugged into something else, all right? Software ports are virtual connections that used in networking to manage data transmission between software applications. All right, so hardware ports are physical, software ports are virtual. Both hardware and software ports work together to facilitate seamless communications between devices and networks. So you pretty much have to have both. Okay, so hardware ports. Okay, so some examples here are USB, HDMI, Ethernet. USB or Universal Serial Bus port is commonly used, in fact it's pretty much everywhere, for data transfer and power supply between devices like computers and peripherals. HDMI ports are commonly used to connect devices for audio and video, so probably like a computer monitor of some description. Output commonly found in televisions and monitors. So USB could be like for data transfer and power supply between devices like computers and peripherals. HDMI is often for audio and visual outputs like televisions and monitors, and Ethernet ports provide network connectivity, allowing devices to connect via the internet via wired connections, or connect to the internet via wire. And Ethernet port's not the only type of port that can do that, but that's the most common one that's known. Okay, there are different ports that do different things, like, okay, hardware ports enable the connection of various devices, including printers, monitors, keyboards, mice, you name it, like your mobile phone often, and other peripherals to ensure seamless integration. Data transfer ports facilitate efficient data transfer between components, enhancing communication speed and reliability within a system. And certain hardware ports can also provide power supply to connected devices, contributing to the overall functionality of the system. As I said, like the phone, a lot of mice, that sort of stuff too. Okay, so software ports now. So we're moving into the virtual. We've gone from the hardware to virtual now. What are software ports? As we've already said, software ports serve as virtual interfaces that facilitate communication between different applications over a network. Each software port is identified by a unique port number, which helps in routing the data correctly to the intended application. Like common examples might be port 80 for HTTP or Hypertext Transfer Protocol, port 443 for HTTPS, which is Hypertext Transfer Protocol Secure, which HTTPS is one that's used pretty much 99% of the time because HTTP is not secure. And security in anything you do with IT is tantamount, especially cybersecurity, but it's security, networking in cloud, you name it. Even if you're using the internet as an everyday user, you don't want to be using HTTP because it's not secure. So data packet direction. So how do software ports manage network communication? How do they work? Software ports are essential for directing incoming and outgoing data packets to the appropriate applications, assuring data flow. Ports facilitate seamless interactions between various software applications and network services, enhancing overall communication facility. So if you've got port 443 for HTTPS and it's going to talk to this application over here, the computer will go, oh, this is incoming secure website, usually HTTPS, and it's going to like a database port, something like that. So port numbers and their significance. Port numbers are essential for identifying specific services and applications on network devices. Traffic distinction. They help distinguish between types of traffic, network traffic especially. So they distinguish between different types of network traffic, facilitating efficient data communication. And they ensure that data is being directed or routed to the correct destination for good communication. Okay, protocols associated with ports. Okay, so some things you may or may not know is TCP/IP and UDP. The TCP is Transmission Control Protocol, ensures reliable and ordered data transfer, making it suitable for applications where accuracy is critical. UDP, User Datagram Protocol, is designed for speed while allowing for faster data transmission without the overhead of error checking. So TCP and UDP serve as distinct purposes in data communication, catering to different application needs based on speed and reliability. So TCP is quite reliable. UDP is faster, but does not have error checking. All right, so that's something that like maybe video could be UDP, but like file would have to be TCP. So other common protocols, HTTP and HTTPS, FTP and SSH. HTTP and HTTPS are used for web traffic, so they're to do with browsers, ensuring secure and reliable communication between clients, so like a computer and a server. Okay, File Transfer Protocol, or FTP, is used for transferring files between a client and a server over a network. And you really should use SFTP, which is Secure File Transfer Protocol, okay? It's important that you have security because it's encrypted if it's secure. FTP is not secure. SSH protocol or secure shell is protocol for secure remote access. So if you've got a remote worker, for instance, to network devices, ensuring encrypted communication. So if you've got someone who's working remotely, they would be connected through some kind of SSH protocol in the most cases, all right? Data packaging. Protocols define the structure in which data is packaged for transmission, ensuring that it's correctly formatted. Protocols outline how data is transmitted over networks, specifying the methods and paths for efficient delivery. Data reception. Protocols establish procedures for receiving data, ensuring that it is correctly interpreted by the receiving device, and reliability and efficiency. Each protocol is designed to optimize data transfer, ensuring reliable and efficient communication across the network. Security and vulnerabilities. Okay, so any software port or even hardware port that is open, that is, it's not been closed or not been blocked, or no, there's no like filtering on it, it's called an open port. And they can be exploited. So open ports can be exploited by attackers to gain unauthorized access to network systems, posing very big, significant security risks. So you should close unnecessary ports that should not be open. Really, that's what you should be doing all the time. Misconfigured ports may allow, so if a port has not been configured correctly, can allow unauthorized access, increasing vulnerability and potential for data breaches. And awareness of common port vulnerabilities is essential for enhancing overall network security and preventing cyber threats. And there's a lot of cyber threats these days, so this is vital for preventing that. Impacts on port vulnerabilities on security. Data breach risks, and that's a huge risk because you can lose money, you lose company reputation. So port vulnerabilities can expose sensitive data, leading to significant breaches and can endanger organizations. Plus you can get fines, legal people can sue you, all that stuff that you don't want. Unauthorized access to port systems can result in operational disruptions and security incidents. Understanding vulnerabilities is crucial for implementing effective security measures to protect ports and their operations. Okay. So best security practice or best practices for securing ports. Closing unused ports, as we already said. Reducing potential entry points for unauthorized access. Monitor your network traffic. Regularly monitoring traffic helps identify suspicious activities and potential threats, enabling timely responses to security incidents. Use firewalls. Implement firewalls, which can be software, hardware, or both. So that's something you can look into. It's critical for controlling incoming and outgoing traffic, thereby protecting the network from unauthorized access. Future technology. Faster data transfer rates. So recent advancements in port technology have enabled significantly faster data transfer rates, improving efficiency and productivity. Like it also been around for a while, but like fiber optics, satellite communications, Wi-Fi, enhanced connectivity options, new connection options like USB-C, streamline the connection process by combining power, delivery, and data transfer in one cable. So what are the innovations in software port management? Traffic management systems. Innovative traffic management systems optimize data flow, reducing congestion and improve overall network performance. And you should really invest in a traffic management system if you're on some kind of network. Enhanced security protocols. New security protocols are implemented to minimize vulnerabilities, ensuring safer data transmission across networks. Emerging protocols and security measures. So enhancing data security. Emerging protocols are designed to enhance the security of data transfer, protecting it from unauthorized access and breaches. Efficiency in data transfer. These protocols also aim to improve the efficiency of data transfer, ensuring faster and more reliable communication across networks. And robust security measures. implementing robust security measures is essential for safeguarding network communications against potential threats and vulnerabilities. So, like, in conclusion, knowing how ports work and what they do and what they're used for is very important for computers, for IT, for any computers you're using, networking, cybersecurity, and all that stuff. Okay, so it's important, is crucial for effective communication in modern technology, pretty much. Awareness of the functions and uses of ports enhances data transfer and overall system performance. And vulnerability and trends, recognizing what the vulnerabilities are and future trends in ports is vital for maintaining system security and functionality. And you should be worried about all this and more, but this is a very, very brief overview of it. Okay, so thank you for your time.